Have you ever wondered how coffee is decaffeinated? Or how ice skating works? The answer lies in something called phase diagrams. This is an example of a typical phase diagram. This specific one is for carbon dioxide. It represents how a substance moves through all three of the phases at different temperatures and pressures. This is called the triple point. It is the temperature and pressure at which all three phases can exist simultaneously when all the processes are in equilibrium. This is the critical point, and that is the temperature and pressure at which the liquid and gas phases become indistinguishable. Above the critical point is what we call a supercritical fluid, and that is this yellow area right here. It has properties of both a liquid and a gas. An applicable use of supercritical carbon dioxide is the removal of caffeine from coffee beans for decaffeinated coffee. When coffee beans are soaked in supercritical carbon dioxide, the caffeine can actually dissolve in this liquid, where it couldn't dissolve in either a liquid or a gas. And the coffee beans can be removed, and the caffeine is strained out in the liquid. Another interesting thing to notice about the phase diagram of carbon dioxide is the pressure at which we live. This is 1 atmosphere of pressure at sea level. If you follow this line across, you can see that there is no possibility for carbon dioxide to be a liquid. This is why we use dry ice or solid carbon dioxide to put in coolers, because it can't get anything wet because it will immediately sublimate to gas. This is a phase diagram of water. It is different from all other phase diagrams because of this line. In water, this line is negatively sloped, whereas in all other phase diagrams, it is positively sloped. This happens because of the way water freezes. When it freezes, it becomes less dense, whereas in other liquids, it will always become more dense as it freezes. A practical application of the unique characteristic of this line can be found in ice skating. The solid ice beneath your ice skates exists somewhere around here, at a low temperature but normal pressure. However, when you cross the ice with your thin blade of your ice skate, it becomes more pressured and therefore moves up at a constant temperature to cross the threshold and melt. That means when you're ice skating, you're actually skating on water. It's important to understand phase diagrams, as the applications of them are pretty crazy and pretty useful.